Hello, good afternoon. How are you? My name is Mark Pous, and if you want to learn about IoT, Python, and containers, you're at the right session. If not, yes, stay here because you will learn a really interesting technology that I think it can be useful on your Python daily life. So let's start. In this talk, we will connect with Python, some hardware such as a Raspberry Pi, and how to interact with sensors like this tiny sensor here, that it's a temperature and humidity sensor. But also, I'm going to show you what happens if you don't need only to use one Raspberry Pi, but multiple Raspberry Pis with the same code. How do you scale to connect this simple Python code that reads a sensor with temperature and humidity to a lot of Raspberry Pis or similar device types? And the solution actually is that containers love IoT, and this is why I'm going to do this session and show you how to do it in a really easy way, because you have to understand that connected devices are everywhere. Most of the devices that are around you that have electricity, probably they have PCBs like this green thing that we have here, and they have like a lot of chips, and some of them are connected to the internet. But I also understand that you can be this type of Python developer that you understand what's a single page application, for example, but you get lost when you get into a single board computer like this. But you also have to understand that most of these things are programmable, and maybe some of the things that are around you, they run with Python. So Python is great, but sometimes when you get into the low-level details of a device like this, that's a new real wall, that it's hard to understand. So this is why I'm here, and I will try during the next 15 minutes to show you how to make it happen. So let's start. Let's have a simple IoT device. So this is a Raspberry Pi 4. It's a single board computer. That means that it has a CPU, some RAM, and so on. And next to this, there is this sensor. It's a BME 280 that actually it has temperature and humidity and some other environmental sensors to tell us what happens around us. If you have a Raspberry Pi 3 or 4 with you at home, grab it, go quickly. I give you some seconds because you will be able to follow me during this talk with a live demo. And even if you don't have a sensor, that's simple. So you can do it with a random number, what I'm going to do. So let's start with something that it's not part of the demo. Let me show you what happens if you want to run this sensor on Raspbian, for example, that it's an operating system that runs on a Raspberry Pi. So Raspbian, it's like the official Raspberry Pi operating system. If you download it on the SD card, you put it there. And my recommendation, if you want to use this sensor, it's to Google for this BME 280 Python library, and you will appear this PyPy project with a BME 280. It's pretty straightforward to install it. So yeah, you do pip install the library. You get install it on your Raspbian, that it's a Linux operating system. Then there is a source code on the website. You just copy and paste. You can use nano, vi, whatever you want. And finally, you just run Python and the code that you just paste, and it gives you the temperature and humidity. So in this case, there is a temperature of 29 degrees, pressure and humidity. So at this point, hardware sounds awesome, sensors sounds really cool, but when you want to get big, that sounds complex. But let me show you how to deal with that. So how to get this code into 500 devices just with one click. And to do it, that's simple. So we will use Docker containers, and we will use Balena. Okay, Balena, it's a fleet management IoT platform. That means that it enables you to manage the fleet of devices, connected IoT devices, such as a Raspberry Pi, a Fin, and some other Jetson Nanos and other devices that you can find around. At Balena, we love open source. Most of the products are open source. And then what it's not open source, like Balena Cloud, has a free tier of 10 devices forever. So I'm sure that you will be able to do this with a free tier. Who is Balena? So probably most of you are asking this question. But I would like to ask you a question, and I would like you to raise your hands. So who has used ever Etcher? So if you have used Balena Etcher, you have probably used Balena software. So we like to simplify things, and by simplifying, it's what we do here with Etcher, right? We help you in a really easy way to flash SD cards or USB sticks. So that's what we do with IoT as well. We try to simplify in a really easy way how to run containers on IoT devices and deploy in multiple devices in a really easy way. But what does it mean with fleet management? So it means basically what I explained. So you can run it on one device, as I show you on the Raspbian operating system. It's pretty straightforward to run it in one device. The main difference, as you're going to see, is that I didn't show how to install Raspbian and how to configure the Wi-Fi, etc. And it's pretty tricky. So you will spend a couple of hours to do that Raspbian from zero, from opening a box with a Raspberry Pi till you get that code running on your Raspberry Pi. So what I'm going to show you, it's going to be done in less than 10 minutes. And not only that, then you can use it in 9 devices or even more. Because, but what Balena helps you, it's on this massive deployment of devices, and as well, the same code, the same Python code that we are going to use can be running on different devices that actually need to share the same architecture or device type, as we call it, but they can run on different devices that belong to your application that runs on Python code in this case. And because when you are on IoT, all your devices are everywhere. So sometimes are not on your table in front of you. They are on places that are inaccessible. So this is why it's really important to have a tool that manages your fleet and actually enables you, for example, what happens when you have a bug on your Python code and you need to release a new version. So this is where Balena actually helps in a really easy way. So where is my Python? Let's do the Python. Okay, so let's get into the demo. So I have here my Raspberry Pi 4 with a sensor BME 280. Actually, I bought this BME 280 sensor on AliExpress for a couple of euros. You can find it on Amazon as well if you want to have it very quick at home, if you want to test, to start with single board computers and IoT with Python. But I really, it's a very simple sensor that works really good, and I strongly recommend. And actually, we have other libraries at Balena, like Balena Sense, where you can, get visualizations in a really simple way with Grafana. So let's start, showing you some Python. Let's do it. First of all, let's create a Balena account. So I already have it. So this is my Balena account, and I'm going to create an application called VME 280 PyBCN. And I'm going to say that this is for a Raspberry Pi 4. Okay, and I will create the application. What we are going to do here, it's create the application. We are going to add a device now, as you're going to see, and we are going to download the operating system. Here we are going to say we want to add this device. So this is we are going to introduce the Wi-Fi credentials that I have at home, and we are going to flash this SD card with Balena Etcher with the operating system image that I'm going to get download right now. Okay, so let's do it. We have it, so let's open Etcher, have it here. Let's say flash from file. This is the image. I select the target. I already introduced my SD card, my SD card reader, and I will click flash. We are flashing the SD card with a really simple tool like Balena Etcher. If you never use it, it's very handy. A lot of users use it to flash or burn a USB stick, for example, if you want to install a new operating system in your computer. And once we will have this SD card burn, flash complete, successful target. Let me get the SD card. I introduced the SD card on my Raspberry Pi 4, and I'm going to power it up. And what it's going to happen in a sec is that the device, because it has all the Wi-Fi credentials from my office here at home, it will appear on the Balena Cloud dashboard. Meanwhile this happens, let me open the terminal. So we start doing the Python code that we talked before. For the Python code, let's create a new project, BME 280 balena. All right, we see that the holy shadow is getting there. Okay, we created this, we have nothing here. So we are gonna do, actually, yeah, let me explain what is happening here. Maybe that makes sense. So we we have an application with one device, but we have nothing, no applications on the device. Having said that, every device that it's running this image or Balena OS have a supervisor that actually, as you can see on the logs, it's getting a start, and it's connected with the Balena cloud, and it's checking all the time if there is a new application or something to get, and it creates this SSH connectivity with the cloud. But let's get back to the terminal. So as I told you before, when I show you how to do it with Raspbian, we have here the code. Actually, so let's copy this code here. It's a pretty simple code. Let me show you. So let's call it BME 280 project.py. Don't call it same name BME 280 because the library it's called like this. So it usually brings problems. But this code actually imports the bus library that it's forwarding the GPIO of the Raspberry Pi, imports the BME 280 that probably has all the libraries and all the packages to decode the signal from the sensors and make sense of them. Has some variables here like bus, it do the calibration, and then it gets samples of data from this BME 280 sensor from the bus and address, etc. Gets the data, and we just print the data. We just print the ID, the timestamp, temperature, pressure, and humidity, and we also do like print the data like the object. Okay, so it's a pretty simple code. As I said, if you don't have the sensor, my recommendation is I usually do it with a random number. So I put like a random generator number here, and I just print this random number. So this is why I say, hey, get your Raspberry Pi with me so we can do it together. Now it comes the most interesting part, that it's to create how to put this into a Docker container. So let's create a Docker file, the template that it's where we are gonna. So you have to understand that now we are gonna do a recipe. So maybe let's explain what is a container. So a container is a package or a software that actually packages what you need to run a service, or to run the software that runs a service. So it's not like a virtual machine. When you install a virtual machine to run a service, you need to install the full operating system with packages, update them, etc. Containers are more efficient or more optimal. What you do is just to install the services that you need with the operating system that you want, and that's really useful. So this container will share the kernel sources with the service that you are running on that container. And the interesting part is that you can have one piece of code running on a container with a specific kernel or operating system, and you can have another container that talks to the other with another operating system. So that's really useful. So to create the Docker file template, we are gonna create this recipe that will run on a fleet of devices, as I showed you before. So first thing that it's important is to create to say what is these kernel sources that are gonna be used on my fleet of devices. So here what we are gonna use is balena lib or a balena Docker hub image, and we have about more than 2,500 images running with balena libs. That means that we do all the combinations of architecture of devices, operating system, languages, so you have exactly the services that you need to run something specific. On this case, we are going to use one image that we have on Balena with the latest Python sources that you need to run a Python application. So you will see. Okay. So what we do is we say balena lib, and then percentage balena machine name. That means that as I told you before, this source code will be or these containers or this application on Balena will be compatible. Can be compatible with Raspberry Pi 4, Raspberry Pi 3, running on a 64-bit operating system as Balena support, and other devices that are compatible with this ARM 64-bit architecture. So that means that we can have different types of devices. And here what we say is, hey, just download the kernel sources exactly for this device type. In this case, you're going to see in a bit, when we just push the containers to Balena, that Balena is going to translate these into Raspberry Pi for 64 bits. Okay, and now we say, that we want the Python image and the latest. Okay, you can specify the version that you want. I'm going to say that the work there that we are going to work, it's user source app. We are going to run something important, that it's pip install RPI, BME 280, that it's the library that we are importing on the source code as I showed you before. And copy this here and cmd Python and BME 280 project.py, if I'm not wrong. Yeah, BME 2 project. Okay, so now what we need to push this this project to Balena, it's to install the Balena CLI. Okay, I already have installed it. I'm gonna miss that part, but just Google Balena CLI. Okay, the command line interpreter that we have, and depending on the operating system that you have, if you have Windows, Mac OS, and Linux, it's super simple. In my case, that I do have Mac, I just went here, I get the latest release package, and I install it. Okay, so what then you do Balena help, and then you get all the information from Balena. First time that you're gonna use it, you're gonna need to do Balena login. Okay, I think I'll already do the Balena login. So I'm gonna push these to what was the name? BME 280 PyBCN. Let's leave it here. So BME 280 PyBCN. So we are saying, hey Balena, get the containers that we have here on this source code, build them on your builders on Balena Cloud, and just inform all the devices connected to this application that there is a new code that they can start downloading. And they can start running this service. So as you're gonna see, once the code is released properly and the containers are up on the Balena builders, the supervisor will get informed, hey, we have new code. It will download the latest source code, and it will start the new services with this container. Okay, so we see that, yeah, now the device says, hey, the kernel sources from this container, it's on Balena lib, Raspberry Pi 4 64-bit, Python, as I showed you before. The board there, we do the pip install, that it's here. We don't have the latest version of pip, but that's okay. We would be able to run on the Docker file template, like a pip update to the latest version. That's possible as well. I didn't do it. And so that means that every time that you push a newer version, the pip will get updated. Okay, so successfully built, uploading the image, and if everything goes well, we will see the Charlie the Unicorn. All right, so we have Charlie the Unicorn, and on the other hand, we see that the supervisor start downloading the image that we push to Balena, 100%. Let's see now. Yeah, what we see here is that, yeah, the service gets exit because we only execute once this Python code that ends, no, when the data is printed. So what I'm gonna do is I will create an infinite loop on the Docker file template to don't touch the Python code, to see that it's possible as well to create that simple code and on the Docker file template, and executes every 20 seconds. But actually it will be a device variable that you have on the screen that can be configured through Balena. Let's do it. Okay, so let's do pi Docker file template, and we will change this for this So we will do while, it's an infinite loop, do Python BME 280, project.py, and then a sleep, and then here we are creating interval, this variable for balena, that if it doesn't exist, it's 20, and done. All right. Now let's do another balena push as we did before. And the interesting part here on balena is that balena is gonna get the previous image, and it will get the differences, the deltas between the previous image and the current one that we are pushing, and it will only push the latest version, or the latest changes that we made. Okay, that's one of the things that at balena we do, is to make the containers deployment more efficient. Okay, now that we successfully upload the image, what we are going to see on Balena Cloud is that the supervisor, it's downloading the delta from the image, and once it have it, it killed the previous image and it runs the new one. So as say the new one, it's gonna introduce, it's gonna read from the BME every 20 seconds. So it's gonna call Python to the and the code, on the source code, from reading the BME, reading the sensor every 20 seconds. That's right, yeah. So that's right, every 20 seconds. And the interesting part is that if we change this variable interval here, we can actually get this data at the moment that we want. And that's all. That's a demo. That's the Python part. But let's recap. So we have remote sensors. So we have IoT, right? We have single board computers such as Raspberry Pis that probably you can have at home, or you can buy it for some euros, dollars, or whatever currency you use. And then I show you how to run containers with Python code in a really simple way and a scalable way using Balena. I have to say that, the Balena Cloud that I show you, you use the freemium up to 10 devices, but there is as well the open source solution. It's called Open Balena. Just Google it or go to balena.io website and you will see. And you can download it. On the other hand, Balena OS, it's open source, and Balena Engine, we actually don't use Docker containers, but Balena Engine, it's not open source, but it's free to use. More things that you can do or you can try at home. So go to hub.balena.io and you can download different applications. Some of them running on Python, some of them not. But you can install from a LoRa gateway to Balena Sound to manage your hi-fi equipment at home, to Scratch, or you can manage your old printer with a Raspberry Pi with the Balena caps. And if you like it and you want to know more about Balena, so every Friday, 4 p.m. UTC, there is the IoT Happy Hour where we explain different projects. We invite developer community people with awesome projects, and we have some fun during an hour explaining how to build funny projects on IoT. And if you have any question, I'm here just to answer them. So feel free to send me the questions. And here are my credentials, so if you need to write me a message or whatever, feel free to write me at my email. And it was great to show you how to build your first Python IoT container on a connected device. All right, have a good afternoon. I'm now for the questions. Let me read them. Bye.